Hey all, welcome back to Science in 10. So, every so often, while the Earth is orbiting the Sun and the Moon is orbiting the Earth and the Moon will get in each other's way. Not literally, as in like one will run into the other, but every once in a while the Earth or the Moon will block the other's view of the Sun. Occasionally, when the celestial bodies align just right, we get an eclipse. Let's explore how eclipses work. Just like every other object in the solar system, the Sun shines on one side of the Earth or the Moon at a time. As a result, the physical mass of the Earth, or Moon, casts a shadow off into space in the direction exactly opposite of the Sun. But this particular diagram isn't exactly correct. Here, we're imagining the shadow cast by the Earth with a cylindrical shape heading off into space. The problem with this model begins with the fact that the Sun is so much bigger than the Earth. This image shows the Sun and the Earth to scale with respect to their sizes, but not distance apart. Here we see that the Sun is about 109 Earths in diameter. And here's the Sun and the Earth fully to scale. Whoa, not much to see here. So, to illustrate this next part, we'll go back to using a model that isn't to scale. Since the Sun, the light source, is so much larger than the Earth, light from the top and the bottom of the Sun, traveling in a straight line from where it was emitted, reaches the top and the bottom of the Earth. This produces zones of partial and full shadows behind the Earth. The full shadow, where no sunlight reaches, is the umbra. The umbra is shaped like a cone pointed directly away from the Earth. The zone of the partial shadow is the penumbra and is shaped like a cone with the Earth at its apex. Just like the Earth, the Moon also has its own umbra and penumbra. And just like the Earth, the Moon, and other objects in the solar system, objects on Earth also have an umbra and penumbra. That fuzzy zone that's around the outside of a shadow of an object that's kind of far away, yeah, that's the penumbra, and the dark patch is the umbra. Eclipses occur when the Moon's orbit brings it directly in line with the Earth and the Sun, either with the Moon between the two or on the opposite side of the Earth. When this happens, either the Earth or the Moon will pass through the other's umbra or penumbra. For a really high-tech demonstration, let's head out to the yard and use a model Earth, Moon, and the actual real Sun. In the first part of this model, the Earth is casting a shadow onto a piece of plywood. A lunar eclipse occurs when the Moon's orbital path takes it through the Earth's shadow. A full or total lunar eclipse occurs when the Moon passes completely through the Earth's umbra. A partial lunar eclipse when part, but not all, of the Moon passes through the Earth's umbra. And a penumbral lunar eclipse happens when the Moon passes through the Earth's penumbra. Here's a sped up video courtesy of the Griffith Observatory in Los Angeles of a total lunar eclipse in 2018. Notice how the Moon turns a blood red during the peak of the eclipse. It's not completely obscured by the Earth's shadow, rather blue wavelengths of light are scattered by the Earth's atmosphere and only red light passes through to illuminate the Moon at this point. When the Moon's orbit places it directly between the Earth and the Sun, the Earth passes through the Moon's shadow, producing a solar eclipse. Because the Moon is significantly smaller than the Earth, a solar eclipse will not be visible everywhere on Earth. Depending on your location, you could experience a total solar eclipse, where the Moon completely blocks out the Sun, a partial solar eclipse if the Moon only partially blocks the Sun, or perhaps no eclipse at all. Here's a quick time-lapse video of a total solar eclipse that happened in August of 2017. To do a quick recap, lunar eclipses happen when the Moon is directly opposite from the Sun, and solar eclipses happen when the Moon is directly in front of the Sun. So this would mean that every full moon would be a lunar eclipse, and every new moon a solar eclipse, right? Not exactly. Recall that the Earth orbits the Sun within the plane of the ecliptic. However, the Moon orbits the Earth in its own orbital plane, which is inclined about 5 degrees to the ecliptic plane. With the average distance between the Earth and the Moon at 384,000 kilometers, this means that the vast majority of the time, the Earth's and the Moon's shadows are nowhere near each other. For an eclipse to occur, two criteria with respect to the Moon's orbit and position must be satisfied. 1. the moon must either be in full or new phase, where it is oriented opposite the Earth from the sun, or between the Earth and the sun. And 2, the moon's orbital path must intersect the ecliptic plane. When these 2 criteria happen, we get an eclipse. When they don't, we don't. And that is a quick story of eclipses. See you next time. And I'd like to thank the dogs for letting me borrow their Kong for this video.